Moin! This video is part of the scientific Python programming course at the University of Bremen. In this video we will basically cover very basic Python data types and control flow structures, and this will already enable us at the end of this course, at this lecture, to write small Python programs, very useful small Python code snippets. We will do this this session exactly the same way as we did before, step by step. So I will go at the speed that you have time enough to type those things also at your computer, and I would also encourage you to do so, because if you type the commands yourself already during the lecture, during this course, then you will learn it much faster. So in order to do so, please start now your VirtualBox instance and the Ubuntu machine which we installed. As you can see, I have already done that. And I have already also downloaded the slides for the current session. The slides can be found at this URL. Just to remind you, this is the URL of the website of the course, and here you can download all the slides. So please, if you didn't do so, do it now that you have it also on your desktop. As I already said, we will cover here data types, control structures, and some character formatting in at this session. In order to be able to follow this session, we need to install a few more packages to our Linux distributions, to our Ubuntu distribution, and this is the first thing we will do together. And in order to do so, we would have to start here the LX terminal, so basically the command line window. At your Ubuntu instance, it's black on white, so basically it has a white foreground and black background. I have changed it at my instance so that you can read it better, but otherwise everything will be the same. And in order to install something, we have to gain root privileges, so we are writing sudo, then we are using the tool apt or apt-get, doesn't matter, I will just use apt, and then we are giving the tool apt the command install. It should install, and it should be the package Python3, IPython3, and the so-called Jupyter Notebook. And if you type that, you just hit enter. Then you have to enter your password. You should remember your password, of course. And if you enter your password, it is basically offering you all the packages which it wants to download, which you should accept just by hitting enter. And then basically it will download all the packages from the central repository, from the repository which has been selected during the installation automatically by the installation tools. And that shouldn't take very long, depending on your internet connection, of course. But those are just 90 megabytes of packages, and now the packages are unpacked and installed, right? But it goes usually quite fast. In the meantime, while the installation is running, we can just have a look at the slides. So basically, if we just change here to the slides window, in the meantime, I can tell you that we will cover Python. Python is a very nice programming language, and it's the one which is used a lot in scientific programming. So basically, this is the mostly used script language in scientific programming, I would claim. Julia is now getting more and more popular, but still Python is orders of magnitude popular at the moment. Just to remind you, Python comes in two different flavors, in Python 2 and Python 3. We will only cover Python 3. This is the actively developed. Python 2 is basically not supported anymore, but there are still a few projects around which are only in Python 2. The difference is very small. There are a few small incompatibility changes which has been done in Python 3. Basically, the language had been cleaned up. When you want to learn Python, there are numerous sources how you can do that. Of course, in the internet, you can have a look on the official Python site. For example, there are also tutorials, and the library references is something you should definitely know. Then there are a lot of web pages where you have Python tutorials at different levels. For example, Dive into Python is one of my favorites if you want to learn the object-oriented programming in Python, or deepen your knowledge in that. For example, that's a very, very nice site, and so on and so on. And of course, there are also printed books if you prefer that. One or two books which I can recommend, which I liked a lot, is from M. Lutz, learning Python and programming Python. The learning Python is a very, very, very detailed introduction into the language. So basically almost all features Python offer you can find in that book. Okay. Now, how can you interact with Python? So if you want to execute or write Python programs and execute Python programs, how can you interact? And there are various ways you can do so. And I will show you. Just let's open another shell window. And one possibility, you just start Python 3. Python 3 was already on your system, so this is not it's not installed by this installation process which is running in the background. And for example, you could say 3 plus 3 and this hit enter and it says 6. So that's one way you can just enter things in the Python interpreter. If you want to exit, you're just pushing Ctrl D or STRG, Steuerung D, and then you exit the Python interpreter. Okay, let's have a look whether the installation has finished. It's always finished. It's quite good because then I can show you the second way how to interact with Python, and that's an IPython IPython interpreter. I will start that. It's similar as Python, just with the I at the beginning. And this is also a similar interactive tool. However, it's a little bit more user-friendly. You can, here you see the prompt is a little bit different, and for example, it is also enumerated. The input and the output is enumerated, so you can access later to something which was produced before, if you like. Again, this one is also you can leave if you are pushing Ctrl D. And then if you say you really want to exit, then you just hit enter and you would exit again. Okay, what else? What are other ways you have to do so? You can also run Python as a script. How would that work? It would work by basically creating a file with the content of the Python program. So we have learned that we can use leafpad, the program leafpad, in order to edit files. We will just say leafpad, and then let's call our Python script hello world.py. And then we will just invoke leafpad. Then we are opening leafpad and we will just enter the Python commands which we want to execute. That means we were saying, let's say print hello world, for example. It's a very, very simple Python program. Maybe one trick I would like to ask you to do is if you're ever using leafpad to edit program codes, then it's much better to change the font to a monospaced font. So basically I would suggest here I have Ubuntu regular, just to change it to Ubuntu monospace, and I will now also increase the font size so to make sure that you can see it much better on your screen. So then it's printed in monospace, and that's much nicer to look at if it's a program code. Okay, we will just store it by pushing Ctrl S, or you can go also to menu file and save. And then we will just with Ctrl Q, we will just leave the editor. And now if you make an ls, if you remember, ls gives you a list of the current directory. If you make an ls in the current directory, you see that indeed a file called helloworld.py or p has been created. Now if we want to execute it, we have to call Python 3. This is the program which interprets the Python language, and then we are basically passing this Python 3 interpreter the file helloworld.py. And if you just hit enter, indeed you see that basically the program has been executed and it printed just the string hello world. Okay, so that's already quite nice, but it's a little bit annoying if you always have to type Python 3 at the beginning. And indeed there is a way to avoid that. So let's do the following. Let's edit again with leafpad the helloworld.py program. I will again write an ampersand to start leafpad in the background, so that we here in the command line window we again break the prompt again. So if we wanted, we could just type any command, and I will just basically add a special string here, a special comment, and I'm invoking a certain program which is called which is at the place user bin amp, and I'm just passing this program the string the name Python 3. What does it mean? If I will start this program directly, I will show you in a second how to do that. Then basically it will first call the Python3 interpreter, and whatever follows after this first line will be just given to the Python3 interpreter as an input. Okay, so we save it and we quit it. Now we have to make sure that this file is executable. Just let make an ls-l. You remember, here is our file. You remember we have 3 blocks here of different permissions. The permission for the user, the permission for the group, and the permission for everybody else. And you know this permission can be read, write, so readable, writable, and x executable. Now this script is not executable, the X flag is missing. So we will just add the X flag, so we will say change mod plus X. We would like to add the X flag for the file, the attribute to the file hello-world.py. We just do so. And now if we are listing again in the long format hello-world.py so that it shows all the attributes, you see that basically now we have the X attribute. So basically we can execute it now directly. If you say / in the current directory execute hello.world.py, and then it's indeed happening. Because you can execute it directly, maybe it's not even very important to know in which programming language the script is written. So as the last thing, I will just rename hello-world.py into just hello world without any specific language extension. And then if I say / hello world, like a Unix command, it will just print hello world. So that's also a possibility, and a very often used possibility to run Python scripts. In this tutorial, because we are now a beginner and we want to have more interactivity, we will just do it more interactive in a so-called notebook, in the Jupyter notebook, and that's the next thing you should start. You can check in the meantime when the installation finished. That's the case, so I will just close this window by pushing Ctrl and D, which means the input is ended, so it's closed. I don't need it anymore. And here in this window, we will just start this Jupyter notebook. Okay. So I'm starting the Jupyter notebook. The Jupyter notebook runs in a web browser. It's, if you know Mathematica and Maple, it's a kind of similar worksheet. And then if you start it, you will get basically a list of the current directory. And we would like to create now a Python project. So we are saying here new, and then clicking on Python3. Then it starts a Python3 project, which is completely empty. And basically the same thing which we were entering before, we can in this file we can enter here. For example, we just click into this cell and then we say print and hello world. Let's do it this way. And then if you want to execute it, you will have to push not enter, because enter would just add a new line, but if you shift and enter, then this is executed. And so you can immediately execute in this thing the Python command. The nice thing is you can also go back and you can modify it. If you want to add something, you can do it. And then with shift enter, you're executing again, and then you see the results again. So it's quite nice. You can interactively go up and down and re-execute cells if it's needed. Okay, good. So we will work in this Jupyter notebook. This Jupyter notebook is not that trivial to handle, but it's a very, very efficient tool. And therefore, the first thing I would suggest you to do so is to go through the user interface tour and have a look at the keyboard shortcuts. Okay. And I would suggest you just stop the video now and basically have a look at those two things. Okay, I hope you had a look at the user interface tool and the keyboard shortcut, and now we will continue. As you learned, very important is the switch between command mode and edit mode, because different things are done in the different modes, and how to execute the shell by using shift enter. There's one thing I would like to show you which can sometimes happen to you. Let's assume you're just doing something, so we have a few cells, and now you switch to command mode by hitting escape. You see that here this thing was green before, now it's blue, which means you are in command mode. And then it could happen that you are pushing the wrong button. You are just going around, and for whatever reasons you are pushing the button X, and that would immediately delete the cell, and it's not very nice. And just remember, if you did so and you see that the cell vanished, you can undo it, but only if you do it immediately by pushing the button Z. Okay, Z, like undo, and then it appears again. But make sure that you do it immediately, otherwise it's gone forever. So you should be careful with that. Okay. And the other thing which is important, which I would like to show you, is how to restart everything and rerun everything in the worksheet. And the restart and run all, it's a very, very useful command. Why? Because in this worksheet you can go up and down. Oops. So basically, if you are here, you can in command mode you can go up and down and re-execute things, but that could happen that basically things are not executed in the right order. And if you want to know whether your script really works, your worksheet as a whole really works, if one starts from the beginning and execute the commands, that you can check it. You say kernel, and then you say restart and run all. And then it will ask you whether you want to do it. Restart means it will forget all the variables which you defined, everything which you defined, and then it will basically rerun from everything from the beginning. And you see that an enumeration, it was re-enumerated, so it was the first one to be executed, and this was the second one to be, which has been executed. Okay, so we will have a look at data types in Python. There are basically two different classes of data types, the so-called immutable data types and the so-called mutable data types. We will cover today the immutable data types. Those are data types where the object, when you create it once, you cannot modify it. Think about numbers. For example, if you have the number 1, there is nothing you can modify on the number 1. And this is the first data type which we cover, the integers, just the normal integer numbers. You know, basically in Python you can have an arbitrary range of integer numbers. The only thing you should realize that on most machines, on the machines you have, if you have an integer which is bigger than 2 to the 63rd on 64-bit machines, then it gets very slow because it's emulated integer operation. If it's in a normal range with the machine can handle directly, then it's much faster. Otherwise, you have floating point numbers, of course. Floating point numbers can be entered, of course, as something with a dot, or you can use the exponential notation. If you say the same number would be 1.23 times 10 to the minus 1. That would be the same. So e minus 1 means the prefix which is here multiplied by 10 to the minus 1. Okay, so this is the so-called exponential notation. You can also enter real and complex numbers, so basically complex numbers with imaginary part. Here you see, and you enter that in Python, 2.0 plus 3j, that would be, or 3.2j, whatever, that would be the complex number with the real part 2 and the imaginary part 3.2. So that's also possible in Python. Okay. If you have numbers, what kind of operation can you do with numbers? Of course, the usual operation, addition, subtraction, multiplication, division. I mean, this is I won't go through that. Maybe the division, it's an interesting one in Python. If you are dividing 5 divided by 2, both are integers, but if you divide them, the result can be a float if basically the division of the 2 is not an integer number. If you want to have an integer division, which means you want to leave away the fractional part, then you have to use the / operator, and then you get only the integer part of the division. If you want to have the remainder, then it's the percentage operator. 5%2 means, okay, give me the remainder if I divide 5 by 2, and of course the remainder is 1. So that's basically the same operations you know from other programming languages. The power is, for example, is with star star. So 2 star star 0.5 would be 2 to the power of 0.5, which means square root of 2, and this is 1.41, and so on and so on. Okay, good. You can also compare different things with each other. The comparison operator equal, the equal sign twice checks whether two things are equal. Bang equal checks whether two things are unequal. Less equal, greater equal. Right? The results of a comparison is always a bool value. So for example, if you check whether 3 is equal to, which is apparently not the case, then you get the boolean value false. If you check whether 3 is unequal to 2, then of course you get the boolean value true. So basically the logical values are given back as Boolean. If you try to compare complex numbers, of course, this will not work unless you are comparing on equality. That works, but you cannot order complex numbers. Therefore, if you try to say 3.1j, whether it's smaller than 2 plus 2j, and then you are hitting Shift Enter, then of course you will get an error message because it says that this operator, the less operator, is not supported between instances of complex and complex. If you have two complex numbers, you cannot apply the less operator. I mean, it's quite straightforward, but you can check whether two complex numbers are equal. That's possible because that can be checked, and this is of course here not the case. As I said, the results which you get from comparison, they are Boolean values, and Boolean values you can also combine with the help of logical operators, with the AND, OR, and NOT operators, and you know it from other programming languages. AND, the AND operator, gives true if both of the operands are true. So basically, if I have true and true, then I become true. But if any of the operators is false, operands is false, or I have false and true, or even false and false, then I get always false. Similar with OR, the logical OR, but it's in contrast to the AND, it gives true if any of the two operators operands is true. So basically true or false will be true, but false or false, for example, it will be false, of course, because none of them. And the NOT operator, which we will use also, NOT just turns the meaning of the logicals. So basically, if it was true, it gets false. If it was false, not false is of course true. It's a logical negation. Good. We would like to store or give names to all the entities which we create, so assigning names to objects, and in Python this is done via the assignment operator, which is equal. So for example, if I say a equal 1 and then I refer to a, then it will give me 1. So basically it assigned the name a to the object 1, and this is something you should realize and keep in mind that in Python there is not a classical assignment. A equal 1 means that I am creating an object in the memory which will contain the number 1, and I am just assigning the name a to this object. Now I could also say, okay, b equal a, so I could define a new name b and assign it to a, and then if I would access b, it would also give the same value. But let's have a look what happens exactly in behind the curtains. If you say b is equal a, then what you do is you are telling Python just assign a name b to the object, to the same object to which a also points to. Okay, so basically there's no copying made, nothing. There is the object with the number 1 in the memory. A is assigned as a name, as an alias to this object, and b will be also a name, an alias for the same object. Now if I reassign a, so I say a is equal to, what will happen? That means, what does it mean? So if I say a is equal to, then basically a new object in the memory with the content of the number 2 will be created, and then a will be showing aliasing to this object, will be an alias to this object. And then of course it shows to a different object than b. B still shows on the old object, basically is a name for the old object 1. So if I here now say a, then I get 2. If I say b, I get still 1. So basically that's what I had before. Okay, good. So the thing to note here, we won't see any consequences today, but we will see some consequences in the next one, in the next session. That basically there's no classic variables in Python. Basically these names which we are giving, they're just pointers or aliases. Okay. The last data type I would like to handle today are strings. So strings are easy things with this text which you stored. For example, let's take the variable name 1. and we are just assigning a string. The strings are assigned, if you write a string literally between quotes, it can be either normal double quotes like this, or just apostrophes. That's also possible. Apostrophes like this, it doesn't make any difference. And let's say name2, we take something like this, and then if I access the variable, the alias name1, then I get the, exactly what I have stored before. If your string is very, very long, then you can, and especially if it contains more than one line, then it's a little bit, then you need some tricks. And let's say we define a variable long string, and we will basically write quotes 3 times. And then you see the environment already gives the other 3, the closing marks also additional are extended or automatically appended. And then here, this is the first line. And then we are just hitting enter, and we are entering a second line. And basically now we have a string with 2 lines with a line break in between. And if you shift enter, then it has been defined. And if you know, just let's show the value of long string, you see that is basically first line. Then there's a special character, this \n, which indicates that we have a line break, and then you have the second line. So just remember that the notation for long string is 3 times the quotes. Okay, and that's it. Okay, good. Yeah, what else do we have to know about strings? Strings can be are composed of characters, and you can select some part of the strings if you wish, which is sometimes very handy. So basically, if we define a text, let's define it with some text, and if we want to access the entire string, then we just type the name of the variable. If we, for example, wanted to access the first character, which is the S, and just extract the first character, then we will say text, and we would write within braces, within these symbols, we would write the index of the character. Now what you have to know is that Python starts indexing with 0, so the first character, this S, would be the 0th in Python's language. So if you write txt0, then you get the S character, or if you write txt1 instead, then you get the next one, it is the O, and so on and so on. You can also extract ranges of characters, not just, so for example, if you say I want to have, starting from the beginning, the first 5 characters, or let's take the first 4 characters, then we have here 1, 2, 3, 4, we will get those 4 characters. Why 0 to 4? Because in Python the lower range is always included, the upper range is always excluded. So basically this is the 0th character, the first, the second, the third, and the fourth would be the space. However, if you give a range, the last one, the upper limit is never included. So basically if we take txt 0 to 4, then we get the first 4 characters of the string. You can also add an additional index to the range. So let's say 0 to 8, and if we want to get every second, let's go to the 9th. We want to get every second, then we have just to enter .2, and basically you say, okay, here some text, here is a second, then E, or the 0th one, in steps of 2. So we started by 0, then we get the second, we get the 4th, which is the white space, we get the 6th, which is the E, and we get the T, which is the 8th. Okay, so in steps of 2. If you do not specify the step size as given here, then it's automatically assumed to be 1. You can also leave away the lower or the upper boundaries if you wish. For example, if I'm saying txt.4, so colon 4, so basically I am leaving away the 0, then it's automatically the lower index, then it's automatically assumed to be 0. So if you leave away the left boundary, then it's automatically assumed 0. If you are leaving away the right boundary, let's say txt, and we are starting from the 4th to something, and we are not specifying the upper bound, then you get basically the string at the end. And for example, you can use this trick, for example, to reverse the string. If you say colon -1, which means the lower index is not specified, the upper index is not specified, the only thing which is specified is a step size of -1, then it will just reverse the string, because it's getting from the default from the very beginning to the very end in the steps of -1. But of course, if you have a negative step size, then the very beginning is the end of the string, and the very end of the string is the beginning of the string. And you see the string was basically just inverted. Okay, so this way you can access parts of a string if needed. What you cannot do is to manipulate strings or modify the content of a string. Why? Because strings are immutable. Today we will only cover immutable data types. That means if you specify here, you try to change the zeroth character of the string, and you try to change it, I don't know, to capital S instead, and you are executing it, you are getting immediately an error message which states the string object does not support item assignment. That means you cannot change an item within the string. What you can do is manipulate strings in the sense that you can create a new string with the help of old strings. For example, you remember we had name1 and name2 as strings. You can add them together, then you get basically the two strings concatenated. Or if you have a strings, I don't know, AB, and you multiply it by a number by 5, then it's repeated basically 5 times. So that's possible, but the result is always a new string. You cannot modify a string which has been already created. How can I convert data types into each other? This we see that would be very important for us when we want to deal with the input of the users. You have special conversion functions. For example, if you want to create an integer from any kind of data type, then you have to use the function int. And for example, you could use here a real number, let's say 3.2, and then you would get the integer 3. But you can also use in the int function, for example, the string 3, and then nevertheless it would convert it to the integer 3. So basically we are passing here a string, and it was converted into the integer. Of course, if you pass a string which cannot be converted, like the string A, then of course you will get an error message. But otherwise, if the string which you pass represents a valid integer, it will be converted to an integer. And you can do the same as is shown here with float and complex and so on. So it's all the same for all different data types. Why do we need that? We need that because we will have we will want the users to enter some kind of input, and this we can do with the input function. And the input function delivers a string. So let's have a concrete example. Let's say answer. The variable answer is input, type your answer. What does this input does? This input basically will ask the user to type in something, and whatever the user types in will be stored in the variable answer. Let's execute that, and then you see that here basically a new input field was created, which says type your answer. No, we just tried typing something and hitting enter, and now the program has been executed. And if you now ask what is the value of the variable answer, then it's nothing, because I was mistyping it, so an S is missing. But now if I execute it, is the string test. So far so good. But of course, sometimes we want to enter the user a number, and we want to interpret it as a number. So let's make another test. Let's say num is equal input, enter an integer. And let's execute that, and indeed enter a number. Let's say we are entering the number 42. But then if you look at num, you see, oops, sorry, I was just here putting the wrong button. If you enter num, you see that it's still a string. And if you want to convert that one into an integer, then basically let's call this integer val. Then you have to apply the int function to the string which we just observed, or even to make it more explicit, the naming. Let's say the answer is the string 42, and then we will basically saying that the number which we get, the number is just the integer of answer, so basically the answer converted to integer. And now if we are basically giving out number, the value of number, it's a valid integer. So basically with this trick, we will be able to convert a user input which was received as a string into the desired data type, provided of course the string which the user entered represents correctly the data type in which we would like to convert it. Okay, with that, the first part of this session has been finished. So try to digest whatever we did so, and if you're ready with that and you can handle also this worksheet quite well, then have a look at the next part where we will have a look at the control structures, so that we can have programs which do not have just a sequential flow, but we can jump around and repeat things if needed. Okay, see you hopefully soon.